Hello. The aim of today's capsule is to study a uniform electrostatic field. In this activity we are going to look at the relationship between voltage and the uniform electric field. To do this, we are going to use a rheographic tank. This device consists of a tank and two flat, parallel copper metal frames. The tank is parallelepipedic, transparent, and watertight. The bottom is screen printed for easy identification of the points, 0.5 centimeter grid. This device is designed to draw the equipotential lines between these two frames, point by point. Demonstrate the influence of voltage and distance on the characteristics of the field created between these armatures. Description: P armature connection socket. Parallelepiped tank. P armature. Screen printing. Grid pattern on the bottom of the tank. N armature. Connecting sleeve for N armature. Using the tank. To enable measurements to be taken, the tank is filled with a few millimeters of water. The water, which is slightly conductive, is chosen so that a current can flow between the two electrodes and so that the voltage can be measured. For good quality measurements, the water level should be as low as possible. It should be flush with the bottom of the two electrodes. The height of the water has a significant influence on the voltage measurement when pointing. The silk screen printing consists of two red axes, graduated in millimeter with a numerical indication of the distance in cm from the end plate. A black, bold, centimeter grid. A fine black, 0.5 centimeter grid. A transparent parallelepipedic tank, fitted with two parallel copper plates, D equals 10 centimeters apart, can be connected to a source of constant voltage, U equals 8 volts. A uniform electric field is created between the two plates. A voltmeter is used to measure the voltage UAN between plate N connected to the negative terminal of the generator and a point A with abscissa X in the reference frame, OI, of the tank. The position of point A, which is that of the probe tip, is varied by moving it perpendicular to the plates. Place the tank on a level surface. Position the P armature parallel to the N armature at a distance Pn equal to 10 centimeters. The P armature is connected to the positive terminal of the generator. The N armature is connected to the negative terminal of the generator. Fill the bottom of the tank with water so that it is at least flush with the bottom of the two electrodes. Connect the voltmeter. A black lead connects the CON terminal of the voltmeter and the N terminal of the tank. One end of the red lead connects to terminal V of the voltmeter, the other free end A being fitted with a key tip, used as a stylus to explore the bottom of the tank. The armature N is used as a reference potential. The voltage UAN equals VA minus VN equals VA is measured. Connect the power supply and choose a UPN voltage value. Move stylus A to various points on the axis perpendicular to plates P and N. Observe the change in VA potential as a function of X. Draw up a table of measurements. Draw the curve. VA equals F of X. Conclude. A UPN voltage value of 8 volts is chosen. We vary the position of point A, which is that of the tip of the fingerboard, by moving it perpendicular to the plates. We obtain the measurement table below and calculate the ratio of UAN to X. The curve VA equals F of X is plotted. Since we are working in uniform electric field, so its value is constant, and we know that the unit of the electric field is V to M. This corresponds to the calculated ratio of UAN to X. So the ratio of UAN to X is nothing other than the value of the electric field E, with X being the distance between point A and N. Then, UAN to D equal to E. The probe tip is now moved parallel to the plates. The voltage UAN measured is constant. Equipotential lines. The distance D equals a constant, and the voltage E equals a constant. This gives us that UAN equals E times D equals a constant.